Hello everyone, you're welcome to this channel once again. Today we have another question on aerodynamics point of view. Now let's read to the following question. If an aircraft increases the altitude with speed and viscosity fixed, what happens to the thickness of the boundary layer and why? Once again, if an aircraft increases altitude with the speed and viscosity fixed, what happens to the thickness of the boundary layers and why? This question is theoretical based understanding question, which is very tricky to some extent. But whenever an aircraft increases the altitude while keeping the speed and the viscosity fixed, the thickness of the boundary layer typically decrease, and this decrease occurs due to decrease in density with the increasing altitude. The boundary layer is the thin layer of air adjacent to the surface of the aircraft, where the airflow experiences the effect of viscosity. It can be divided into two regions, the laminar and the boundary layer, and the turbulent layer, which can be represented in a diagram, just like we have. Y-axis and the velocity, and we have the laminar flow and also the turbulent. And we can deduce that the turbulent have steeper slope down to the vertical and the horizontal axis. So therefore, this we can deduce that the steeper one is the turbulent, while this is the laminar. With the respective velocity tending toward that direction. Now, using the question base being asked here that if an aircraft is in altitude, we know very well that the laminar boundary layer and the turbulent boundary layer at lower altitude where the air density is higher, the laminar boundary layer tends to be thicker compared to the turbulent layer. This is because the higher the air density provide more resistance to the transition from the laminar to the turbulent flow. As aircraft climbs to the higher altitude, the air density decreases, and with reduced air density, the resistance to the transition from of laminar to turbulent flow is also reduced. Consequently, the boundary layer tends to transition from the laminar to turbulent flow at an earlier point along the surface of the aircraft. The turbulent boundary layers are always generally thinner than the laminar boundary layers. Therefore, as the boundary layer transitions to the turbulence at an earlier stage with increase in altitude, the overall thickness of the boundary layer decreases. Also, it is important to know that why the general trend is a decrease in boundary layer thickness with the increased altitude. This specific behavior can be influenced by factors such as the shape of the aircraft, the wing size, the geometric platform, and the surface of the aircraft roughness, the local flow condition. Additionally, variation in aircraft design, operating condition, and flow control mechanism can further complicate the behavior of the boundary layer. Thank you very much for staying tuned.